This is the question that we're gonna touch in next chapter, which is chapter 6. Those related to the chapter 2. Based on the things that we learned on the chapter 2, so we're gonna talk about the chapter 6. So chapter 6 is very solid build on the chapters, previous chapters. Just to fresh up a little bit, right? Let's read this short stories and you guys tell me where is the missing $1, okay?
Is the dollar still with the person?
Yeah. Macias?
Yes, Professor, I'm here.
Can we leave the like the opportunity to other students today for this question?
Also, because the $1 mixing is the missing dollar is if like the chart, what I call that person, the person who borrow the money, the missing dollar is that person. Hello, do you hear me?
Oh yeah, I hear you.
I said the missing dollar is keeping with the person who borrowed the money, like the child.
Okay. So how about we see it in from accounting point of view? So how about we prepare a T account?
Okay.
Right?
So if I prepare the T account,
piece of paper and prepare a T account. One is for this. One is for your asset. One is for your liability. Yes.
But if you debit, if you want to do the T account about the liability, like the account payable, example. So I think so. The debit, your account will decrease, like because you pay the $98,000 and your
97, not 90, not
what is it? $97 on the debit side, and your credit side will be the 3 left. You don't pay now, like you own.
Yeah, so you still owe $98, isn't it?
Yes.
No,
what you have doesn't change the fact that how much you own, right?
Yes.
So, and in fact, this should be -1 and equal to 97, which is the price of your shirt. So it can be easily solved because of the liability you have is still 98, even though you have $1 asset, but that asset is not your asset. It's actually owned by other people. It's just temporary, right? So that's why I'm trying to give you guys a insight about this problem. Right? It seems like a math problem, but it's actually a accounting problem. So the objective of this lecture, we're going to talk about the file-oriented approach. Distinguish between the file-oriented approach and the database approach that we talk about in the first class. And then we're going to discuss about the fundamental relational database concept, which is the most important concept in this class, right? Relational database is using throughout this whole course. And then we specify the relationship. And we provide details about the models. And we discuss the database integrities, and we talk about the validation rules. And we also talk about the restriction access, which is very important further in the internal control as well, right? Then we talk about the data dictionary concept, and we're going to talk about the languages. We're going to construct the basic idea about SQL queries. And then we talk about the backups and recovery method. And then explain some other concept, right? So first, what we're going to talk about is transaction processing system, TPS. So TPS is kind of like, I'm helping to organize the transaction. That's the purpose of it. It's using internally because that related to the routine transaction. The external data is not related to the routine transactions. It's stored, processed by, and stored in the TPS, right? So relatively a simple data process need. So if you can see the right side in the bottom, right, we have data input, and we have the process, which is based on the system, right? And then we have output. Source document can be manual entries, semi-automated, and full automation, right? The process can be, basic thing include processing, summarizing, sorting, updating, and merging. And the output can be the summary report, input to the other system, and feedback. So there are two approaches to the TPS. First is file-oriented approach. The second is database approach. So we will talk about these two approaches in detail. But come to the first participation question. So what is the main differences between these two?
This is Sabrina. I'm going to try to answer. So the book says the file-oriented approach. It creates a set of files for each transaction. And the database approach is kind of where you find all the organization depository data that can be shared and used by all the users, for example.
Okay.
I would say this could be the shared drive that a company use, and all the users goes there and use it. I don't know.
Yeah. So last class we talked about the database approach, right? So we talk about it's real time and it's also company-wide. It's event-based and it's also a company-wide repository, right? So let's talk about the distinctive details about this question. Okay. So file-oriented approach. Let's talk about that first. So each application they developed is for a specific data need. Like sales circle is only designed the application for sales, right? Account receivable cycle is only designed for the account receivables. So, for instance, the user can be maybe accountant, or in another situation, they can be the sales team, right? They have their own application programs. For instance, when the users is involved with the account receivable process, they have the account receivable application program, and it's saved in the file, right? And then the sales team involved with the sales process, they have the application target on sales and saved on file separately, right? And then each application files and programs are created based on the need. So what is the drawbacks of this, right? First is data redundancy. So there will be duplication data across different applications. So they will be increase the hardness of the maintaining the data, and potentially gonna cause the problem, right? If the duplications, if you're merging two files at the same time and they have duplications, the system doesn't know which one to drop and which one to keep, right? Next is proliferation of the file. So maintaining file become very complex, right? Because of the duplication. Each application create their own kind of file, and you do not know how to link them together. So the length of the application development is another drawback that we have for the file-oriented approach. Why? Because you cannot share it with intergovernment, like inter-department. You cannot share the file. And it's very independent. So the system is independent, right? But then the data's independency is missing. The data structure and the procedures, right, modified the data need to be in the same program. But the data structure and the procedures cannot be independently modified. So this comes back to the question for the programmer. So you can be the programmer, like when you write queries, stuff like that. You must know the physical location and the layout of the record used by each, program, each process. So increase your workload dramatically. So in summary, right? So it's very complex and it have a lot of duplication, it's inconsistent, and it's not efficient enough, right? So is there any better approach? Yes. That's why we're using the database approach. This is another thing that we're gonna learn throughout the class, right? So database approach, it have a wide repository, as Sabrina just mentioned, right? And it's have all the application, all the program, all together, and every user can share. So database systematically collected the data. And it's very well organized, easy to manage. So different users have different applications combined in the same database management system. So it's like a collective programs, right? Easy to access, and represent well about the data that we have, right? And then we have this huge database that owned by the companies, all the users, shared by all the users. Easy to get, easy to use, easy to store, easy access. Then we can talk about, so it's not like database approach is perfect. There's no flaw. It's not like that, right? So let's talk about the advantages and disadvantages of database approach. So the advantage is data redundancy is eliminated virtually. So each data set is stored only once, right? And then there's no data inconsistency, right? Since the data only stored once, there is no duplication. No duplication, and also make sure that only once there is no, inconsistency for the data. And then it makes sure the data is independent from each other because it is only entered once, right? The change is, monitored. The data structure is separate from the application. And it's very fast response. And it's good for the backup, control, and security task. So how about the disadvantages? So first is the administration of large-scale database require a lot of resources and expertise. A good example is we have data, we have database, we have relational database, and then bigger we have big data. So there is a person saying that human nowadays generated more than like 99 times of the data that they used to generate every day, like information giant like Amazon, Google, right? They have millions, maybe billions of customers. And how they, like each customer, when they using their services, they generate humongous numbers of data. And how they manage their data. That's a very big problem. Their database management system is way complicated than any other entities because of the user number. And then the data integrity. Because of the data integrity problem, because of the complex database management system, right? The configuring of the data is very hard. And you have to have a comprehensive knowledge about all the database management features in order to do so. Once again, the database management system is good for the user, but the user is limited to the internal user, right? This is not accessible outside of the database system, right? And you need to have certain knowledge about it to generate the useful information from the database. That's why we are learning about the query, stuff like that. But before that, you have to have an understanding about what is in the database, right? So keep that in mind when you do the assignment and the group project. You have to have a deep understanding about the relationship between the different database within the database management system. Okay? And then last point, centralized backup, control, and security. Oh, this is the same with the advantages, right? So what they say about this? So the backup, control, security typically are centralized, right? Make the organization vulnerable. Back to the example of blockchain. Why is more secure? Because it's distributed, decentralized ledger. So change one of the things will not change the rest of it unless everybody agree, right? Everybody verify that you are right. But back to the lectures I talk about, it's practically hard to reach unless you control like 51% of the node in the chain, right? So this brings back to the security problem as well. So in this way, if the company using the database management system without having enough idea about how to make sure the cybersecurity infrastructure in the organization is good, then the organization probably will be facing leaking of the important information to the organization, which can be very bad for certain organizations, right? We heard about like the government data breach, right? There was some scandals about, probably at least like 3 million of U.S. citizens' social security number being leaked through the election system, right? So that's like a major cybersecurity breach because of they are using this centralized database management system. In this video, they actually illustrated a lot of useful information. For instance, we know that what they do in creating the relational database is in Access. That's one of the software that we're gonna use in the class, right? And then we also know that it talk about one-to-n relations, which is also an important part in the following lectures. Usually we don't have many-to-many, okay? We have one-to-one, one-to-many, and many-to-many. Usually we don't use many-to-many in reality because it's too much and too messy. So let's talk about the fundamental database concept. The first is dataset, or we call it entity, or we call it table, right? So this is something that the information stored. Like for instance, if we're using Excel, there is a spreadsheet. One sheet is one table, right? But like multiple sheet, if we have multiple sheet and we want to come up with a relation between them, like saying one-to-one relation or one-to-many relation, we're gonna using the Access because it's managing the database. So related data, what that means, like student sheet have all the students' information, right? Student like RUID, first name, last name, GPA, stuff like that, right? Same in this example, customer ID, last name, first name, balance, stuff like that. It share some similarity, but also distinctive. Right? Then we have attribute. Attribute is the characteristic of each respect to each entity. So like, what is the features of this data set? What kind of information stored in this data set, right? Next is the field, which is more like easy for you to remember, is more like the column. The column, okay? It's like the physical space where the attribute is stored. It contains the information about the specific attribute. Like in the blue square, right? It's only contained about the balance attribute, right? And then we have the record, or we call tuple, right? One record is one customer record is distinctively about this certain customer, right? And it's one instance. Like sometimes they have transaction, like transaction number 1, 2, 3, 4, right? It describes the instance of the entity. So anybody can help me with this primary key and foreign key concept?
Yes, Professor. Fiddling.
Okay.
The primary key is a unique identifier of record and a set of data, and the foreign key is a key used to link two tables together.
Okay, that's very good. Okay, let's see. Primary key. Every data set have unique identifier, right? So see, we have like 1, 2, 3, 4 entities right here, right? The first one, customer. This table, the primary key is customer number. The order number. Item is item number, right? These are the primary key that unique identify the data set. And so if there only be one primary key, no, right? So sometimes there are two primary keys. So the attribute or the combination of attribute can be uniquely identified the specific tuple of the table, right? They also call like composite key or concentration key, right? So there are also non-key attributes. We also talk about that in previous class, right? So every field that in the data set that's not primary key are non-key attribute, right? It's highlighted in the gray square. There are also foreign keys. What is foreign key? So foreign key is help you to link it with other database, right? So in the data set, right, neither a non-key attribute or a part of the composite primary key in the data set can be the foreign key. You can see in table, order table, the customer number is the primary key of the customer table, but it is the foreign key of the order table, right? So in the item ordered table, order number is the primary key of the order table, but it is also the foreign key of the item order table. Same. But these two together bring it up as a primary key. Remember that, okay? So foreign keys are used to link the data set together. As the example shows, right? The customer ID and the car ID, right? So those two tables in the previous videos that we saw, so they linked it by the customer's ID, right? So relationships. Cardinality. The way in which data set is related to another data set. So let's explain this concept, okay? So it seems very like abstract, but actually it's very easy. We can just using some example to illustrate this. Like saying building only have one address. One building only have one address. So this is one-to-one relationship. Have one to many. For example, you and your email. You can only you can have many emails, right? But email only have one email address only have one owner. So this is one-to-many relationship. This is the most common in our class and study and real life, right? Especially in the database management database system. Why we see that? Like, anybody can give me another example of one-to-many example?
Professor?
Yes.
For example, like one professor can have a lot of students, but it's like, is that the example of one-to-many?
That can be many-to-many. You know why? Because one student can have many professors, and many professors
Can have many students.
Yes, exactly.
Oh.
Right? So I mean, for our class, yes, we can be like, but like you can have many professors, not just for my class. But if in this class, right, you only have me as your professor, but everybody have me as their professor too. This is one-to-many. But in reality, at school, right, there are many professors and there are many students as well. But you can have many classes, right? I can have many classes too.
Professor can be students with too many courses.
Yes. Student can have many courses and many professors, right?
Yes.
So that's a many-to-many example. That's very good too. But like,
it can also be one person to like one-to-many if we take it in the context that one student have many classes.
yeah, one student have many classes. That's good. That's a very good example. So student and courses, right? So many-to-many.
Professor?
Yes.
This is Anita. It can be another one salesperson and many customers.
Yes. That's great. That's a good example. So you just need to understand the concept. So in the exam, you might be asked, okay, what kind of like a relationship commodity this is? They give you an example. You need to be able to identify what kind of relationship this is. Okay? But like tell you a little bit easy thing. Remember this graph right next to the example.
Professor,
Yes.
I have a question. For example, if we are on the exam and we have an example like an exercise like student to class, which relationship it is. So and we don't have many-to-many, so we can take one-to-many, right?
Oh, so the thing is, in the exam, it's gonna provide you like content. So it's gonna tell you the situation.
Oh,
It's
okay.
kind of like very obvious.
Okay.
It's kind of obvious. You can like get it very easy. Okay? It won't be very hard.
I understand.
Welcome, you're welcome. And then we're talking about the relational model. Relational model, right? So there are many involvement during the past years, right? So there are hierarchical models, which means it's like a hierarchy. Each layer, like a pyramid, right? Like the example right here, right? The accounting department, the marketing department, the IS department have different professor. This is like one-to-many relationship, right? And then they have network database model, which is, the combination of one-to-many and many-to-many, right? The professor teaching different classes and have different graders to grade their class, right? And then the most and dominant and popular database model nowadays is relational database model, which is right here, right? They have professor table, grader table, and then department table. Very obvious. And then you can link it together. See, professor, the color is red, the course color is blue, and grader's color is purple. And then department color is green. So it's all linked together. And it's very visually easy to identify. So the relational database, dataset view as two-dimensional relationship or table. Dataset, field, record. So what is the rule for it? So the table name must be unique in the database. Please remember this rule. Because when you do your group assignment or personal individual assignment, you need to make sure that each table have unique name. Otherwise, it will generate problem, right? And then every table must have a primary key, unique identifier. And the duplicate rule and duplicate column are not allowed. This is a very important rule as well. In the exam, we're gonna ask you to identify the problem. Is there any problem? Is there any violation of this? So the duplication is one thing that you have to look after it. Okay? Please remember this. And then the orders of the row and column is immaterial. This is very simple to understand. So even though it's not by the order, but you still be able to sort it in the order by the query. It's very easy. Just think about in the Excel, you can just do the sorting very easy, right? So the order of rows and column is not very important. Okay? So next, let's talk about what is entity and referential integration.
Okay, Professor.
Masiara Sumaru. Hello?
Okay.
I think so. Entity require that each entity have a unique key. That means no duplicate. Reference integrity is a.
Professor, are you taking?
Hello?
Yes.
Yeah, Professor, I start to explain that. Can you hear me?
Yes.
I don't know.
Please tell me who is talking. Okay.
This is Anita.
It's Masiara was talking and she cut, and I don't know if I was thinking she asked the question. I'll stop. I don't know.
Masiara, how about you let the other student talk, because I think you have a very good class participation. So I want everyone to participate.
Okay, no problem.
Okay, Professor. The entity integrity is the primary key field in the table cannot be null.
How about you talk about the referential integrity? Because Masiara already talked about the integrity, entity integrity.
Okay, you want the referential integrity?
Yes.
Okay, is the for each key must either be null or matched on the existing value of the primary key in the master table.
Okay, so let's get to the details about this. Okay. Yes.
The master table is also the parent table, right?
The master table is also. Can you repeat your question?
Is the master table is the parent table?
Parent table. I'm sorry, can you type it out? Your question? I couldn't hear you.
I said, is the master table also the parent table?
I don't think so. I don't think that's the same concept.
I think so. The concept of parent key, like a key table, I think is based on the entity integrity, maybe something like that. But it's no part of the referential integrity.
I mean,
Okay.
parent.
I don't really understand your question, so maybe after class you can send me an email, and then I maybe can help you a little bit more. Okay.
No problem. Thank you.
So first, I'm talking about entity integrity. So, right? So the primary key in the table cannot be missing value. It has to be unique. Okay? So that's the entity integrity's concept. So as you can see, in this process, the order number is missing or order number is the same. So that's violation of entity integrity. It has to be unique and not duplicate. So what is referential integrity? So foreign key must neither be nor match the existing value of the primary key in the master table. Sales table have the sales order matching and the amount matching with the order table. But the second one, 0303, like 0303, is not matching with the order number. It should be order 301, right? Because the amount and the date is not matching. So this is the violation of referential integrity. So the master table is referring to the order, okay? This order, the second table, the second relational model, the order number is actually matching the sales number, right? So this is the correct one. There is no order number for the sales because this case doesn't really have order number. The customer just walk in and purchase the stuff. This is okay too. Okay? So next we will talk about the data violation rule. So what this means, we want to make sure that the data can be verified. We pretend the erroneous data from being entered into the data, right? So we need to take some action to prevent this. So there are certain examples, right? For instance, there is a range text. So for instance, if I am trying to put the grade for you guys, right? And then I put 101, the system gonna say, okay, this grade only can be from 1 to 100 or 0 to 100. You are out of the range. So I cannot put the data in because I'm putting the wrong range of the data. So this is the range test. Second, we have field test, right? Is this a proper type of the data? So I'm supposed to put a numerical data in the student number. I ended up put like, this student is good. I put the text, then the system gonna generate error messages. Warning, you only can put numerical data in here, right? Next, we have sign test. So this is more like a algorithm, right? It's very common in like accounting. The double entry attribute, right? Decided certain things can only be minus. So if you put positive, right, on that numbers, it's gonna tell you that maybe this is wrong. Please double check. And then we have the length. Like for instance, there are, when you upload like some of the videos on YouTube, on the title section, right, you will have limited number of bytes that you can put in. So this is like the length test of it. You have to be within the length, the requirement. And then we have validity test. So the input is compared with the master data to confirm the existence. Like a simple application for this is sometimes is like a credit line set it by the bank, right? Or how many money you can get deposit, or how many money you can withdraw at a time, right? So this is validity test. And next, completeness test. So a lot of time when you go to some website, when you register for an account or something like that, you will ask, there is a start thing next to the data, which means you have to have that data inputted in the database, right? So even though like that, we make sure that the data input in the system can avoid the unnecessary human error. So then we have valid combination test, right? Logical, is this, mathematically correct? Stuff like that. Another important fact that we're gonna touch in the relational model is restricting the access to the table. This is like the treasurer cannot work as bookkeeping people. Why is that? Because, restrict the access to certain information. So if I am the treasurer and I said, okay, I'm in charge of the bookkeeping, I can get the money, and I said, this is the money I paid for the customer, or this is the money I paid for the vendor, but this transaction didn't even exist, right? I committed fraud. We need to restrict the access to the table. It's also part of the internal control, right? And this we will talk about at chapter 10. So another thing is restricting the access to the table by creating views. So create a view that the sensitive field are hiding or access only. You can see it, but you have the limited authority of seeing it. So this is also another way to restrict the access to the table. So next we have two questions, and I will call somebody to answer the question, okay? The first one is, what is data dictionary? So Thomas, You want to answer this question?
Yeah, I can answer the question.
Okay.
It contains a variety of information about the contents of the database.
Okay, that's very correct. Okay. What are the three types of database languages?
What are the three types of the database language? The three types are DDL, data definition language.
Yeah.
It's used to create tables, set permissions, and define manipulation rules. And DML is data manipulation language. And
okay, that's very good.
The third one is DQL, data query language.
Okay, thank you so much. Okay, so we talk about this, right? So database administrator is the people who are in charge of maintaining the database. In this case, right, for our assignment, you guys are the DBA. Data dictionary is the metadata. Provide a variety of the information about the content of the database, right? So for each element in the database, there will be a corresponding record which describing the element. So it's still very, abstract. So how can we put it in a direct way? This is an example of data dictionary. A lot of time, I don't know if you guys ever use census data. There is a data storage database called American Fact Finder in the U.S. Census Bureau's data website. So that's like a data query combination of the database, right? Every time you downloading any data, they will give you a data dictionary file, which describing how they get this data, right? It's basically a lot of time when in the future, when you work as a data related position in the future, you want to inform your users what are the data that you include, right? The customer doesn't know like what is those unique attribute named. What's the meaning of it? So we need to provide the data dictionary. It's kind of like a user-friendly step that we're taking, right? For helping them to extract the useful information, relevant information, to themselves. We talk about the three languages, right? So every database management system must provide a means of the performing three basic functions of DDL, DML, DQL. So let's talk about it one by one because in each category, there are some subcategories, okay? So DDL, a set of commands used to create the database. Used to build a data dictionary, create the database, describe the sub-schema, and then specify the record or the field with the constraints, which is using for the validation section in the future, right? So the data manipulation languages is a set of commands used to change with the database. To maintaining the database, right? To update, insert, delete, or maybe reorder the data, right? It's all based on the SQL. So you can see the example next to it, right? So in the big database, you can select ID, name, age, gender, college, address, right? From student. So this is a basic query, right? To do the manipulation. Select. Or you can insert a new column from the to the existing column, or you can update. So change a certain record, like the example that we saw before, right? She got married, she changed her name, right? We can just put a query, and then it's automatically update in the database. So data manipulation languages. And then last one, data query languages. So to query a database, right, you can write much longer query in the query languages, right? So you can retrieve data, sorting data, order the data, present the subset of the database. This is the most commonly used in the research and the current data analysis field. Why this is important? Because due to the situation of the big data, right? Sometimes you have a gigantic database. You might not need that much data to do a meaningful interpretation. A good example is I'm going to talk about my own research, right? So I am doing a nonprofit. So nonprofit organization is tax-exempt organization. In order to follow the regulation in the United States, they need to file Form 990 to the IRS. So every year there are like millions of nonprofit organizations in the United States. And they fill this piece of information. And this data entry have like 660 attributes, right? When you do research, you do regression, stuff like that, you don't need all of the data attributes. And you probably don't need all of the data because it's have more than like few millions data for each like financial year, physical year. So you want Maimon to like select like maybe location or zip code, you give a value. Select location equals to what, and year, physical year equals to what, and then the type equals to what. Then you have a small specific data set from this huge data. So that's a big application. So in the exam, I will ask you guys to write the SQL queries accordingly to the exam's content. Okay, so this is the most important part of our study. So there are two categories of data query languages: query by example or structured query languages. So query by example is using GUI for query, right? User will present it with a shell of table to be queried and can enter the examples looking for. Then it can help to do the means of the queries to the table. Another one, the example is presented right here. This is the Microsoft Access interfaces. And you can see, right? You're using the select kind of function. So structured query languages. This is a more widely accepted standard relational database query languages. Using common like select, from, where, something like that. And I have a important recommendation for you guys. So you guys can try to do some SQL query practice from a website called SQL Zoo. So let me show you guys. So this website is really good for you to learn the basic SQL languages. And it come up with some easy exercises, right? So this can be a really good spot for you to start it if you never learned about SQL languages. So any of you guys familiar with SQL before?
No, Professor, I'm not familiar with that.
Yeah, there's
so
GC2S and MIS.
Yeah, okay. So if you are not familiar with this, I highly recommend you to use this as a start point to practice. Okay? It also can tell you if you're doing it right or wrong, and it comes with quiz. Okay? I highly recommend this. So now we are back to the lecture.
Professor?
Yes.
You said on the exam you will access to write SQL query.
Yeah, I will ask you guys to write the query. Okay.
Can you give like a real example, like how we're gonna write this?
No, don't worry about this. It will be on the sample test that I provided to you guys.
Oh, okay.
Okay.
Good.
Don't need to be panicked. It's not like I'm gonna test you right now because we haven't learned about it yet, right?
Okay. Thank you. Okay.
The next part is report. Report writer. So report writer allowed customer report to be generated from the table in a very user-friendly manner. And then we have forms editor, right? To creation of the user-friendly interfaces to the table. The example is like this, right? The forms can be used, it's like a document, but it will be more familiar with the user. So the last part we're going to talk about is the database backup and control and emerging database concept. So there are two types of database backup. First is static backup. So what does that mean? So it's like periodically saving all the information, right? So you can see from the picture, right? You have small database on Monday, Tuesday till Sunday, and then you become full. It's like an incremental process but it's done day by day. So that's why it's a periodic, right? There are dynamic backup. It's an involved version of static backup, right? It's register every of the transaction when the transaction occurred. It means each transaction written to more than one disk. So it provided a backup, right? Facilitate the recovery of the data in case of the file failures of one. So you don't worry, you always have some backup, even though like some of them are destroyed. You still have some backup. The last thing we're going to talk about the database control. So concurrency control. Like it's easy to judge by the name, concurrency, right? So it prevent the same time update to the same data by different user in the different user allowing data input context. What that's supposed to mean? What's the implication of this? So, for instance, right? Me and Professor Miklos say we are having the same access to the grading system, right? But maybe we are same time try to update Sabrina's grade. So this concurrency control doesn't allow me and Professor Miklos to update Sabrina's grade at the same time. So it's locked out. And then when somebody is writing it right now, you lock it. It's the right lock. So this is enhance the database control to avoid the potential duplication of the data entry. Today's most important question for this class, right, for this chapter, is what entity integrity? Okay, just take some second to think about it, and then I will call somebody to answer this question.
Entity integrity means that the primary key field in a table cannot be null and must be unique. Is a unique
Okay.
one.
Thank you so much.
You're welcome.
Any examples of violation of entity integrity? How about Bi Xuan Li?
Yes. Professor, you said the examples of the entity integrity?
Violation of entity integrity.
It's like there cannot be the duplicated items.
Yes, very good. Duplicated primary key, okay?
Okay.
And or missing value in the primary key, okay?
Okay.
Okay, let's do a recap of what we learned so far today, okay? We find out the file-oriented approach and database approach. So which one is better?
Database
Which one is better? Yes, database, right? And then we find out different keys. Foreign key, primary key, composite keys, those concepts, very important. Definitely will be on the exam, okay? Types of relationships, also very important. One to one, one to many, many to many, okay? And then the database integrity. Examples of the rules, also gonna be on the exam, the violation rules, okay? And then the permissions, right? The data dictionary concept, you can just understand it. And the types of database languages, very important, especially the DQL, right? Then I want you guys to learn a little bit by yourself about SQL, using the SQL Zoom, and database backup, right? And the concurrency control. This is what we've been touched for this chapter 6. And another thing I want you guys to know that SQL Zoom have some answer. You can search for the answer. So if you don't understand it, it's okay for you to check it on the answer, right? To get the idea about like why they are writing SQL Zoom, like how they do the query, okay? You have the questions for the next lecture, okay? So we're gonna talk about chapter 7 next class.